Hello everyone, I'm Frank. Welcome to Frank Puzzles, and this is today's hard difficulty puzzle. And it's called The Goldilocks Zone by Marty Sears. And this is the real Marty Sears because I verified that. I got fooled actually by the peddling pianist who was imitating Marty Sears. And yeah, this was a part of a series, and actually this is also part of a series where people are impersonating other Sudoku setters. So this is, I forget who's actually, um, Marty is impersonating somebody else, and then someone else, the pedaling pianist, impersonated Marty. But interestingly enough, the type of puzzles that they're doing are the similar ones. So which actually makes sense because one's impersonating the other. But anyways, this one is called the Goldilocks Zone by Marty Sears. And here are the rules. Normal Sudoku rules apply, which means place the digits 1 through 9 once each in every row, column, and box. Divide the grid into 3 zones. 3 zones, okay? Each zone consists of a single group of orthogonally connected cells, and no 2x2 area may be entirely within one zone. But okay, so this is this is not okay. This is a variant on yin yang where you have in yin yang normally you have uh 2 regions which can be orthogonally connected, and orthogonally just means that they share an edge. Oops. So usually have 2 regions in yin yang because it forms sort of a yin yang sort of shape, and this one cannot be that way. But say like this is normal yin yang rule, where you cannot have a 2x2 with all the cells in the same zone, and you have 2 regions where they're orthogonally connected. But this is a variant on that where you have a 3rd region added in. So I guess it could be, instead of this being blue, this, let's make it red so it's obvious. This would be the normal coloring, this would be a 3rd one, and this would be blue. So this actually works as the variance of yin yang that we're having, because it just has to be orthogonally connected. So that's very interesting what that variant spells out. And remember, it is only one region for each zone. So you cannot have, essentially, you can't, for example, have this be 2 reds, because then this part is cut off from the rest of this zone, which would be the same. Interesting. I don't know what that means. Anyways, okay. The first zone is too hot. Any cell in the hot zone has a value 1 greater than its digit. Okay, I see. I see where we're going from this. So in the hot zone, so I think it was appropriate that we had a red and a blue. Anyways, say this was the red. Except let's remove these 2. Okay, say this was a red and this was just right. And this was too cold. Yeah, we have too hot, too cold, and just right. So say this was too hot. The value in this cell, say the cell contained the digit 5. The value of that cell is a 6 now because it's too hot. The second zone is too cold. So any cell in the cold zone has a value 1 less than the digit. That's what I was assuming. So if this was 5 again, here in the cold zone, the value of that would be a 4 because it's 1 less. And then you have the zone of just right. So say this, and this is only just right now. This is the Goldilocks zone. In this zone, a cell's value equals its digit, like normal. So this would be a 5. Okay, so then we don't even have to color it green. We just have to make it just normal color. Okay, so it could be normal, it could be too hot or too cold. So it could be Goldilocks zone, just right, too hot or too cold. Okay. The 9 objects, there's bowls, chairs, and beds all contain different digits. So this is a unique set, remember. So there has to be a 1 through 9 in this set of 9 cells. In these 9 cells. Or actually, let's make it pink. That doesn't come out very well. But anyways, you get the picture. But each object of the same type has the same value. Oh, interesting. Interesting. So they all contain the same different digits, but each very clever, very clever. I like how he did it. He does not explicitly state something, and I will get into that in the solve. Okay. Zone borders, not box borders. So let's how do we so these are considered box borders that delineate between box borders, but we are not talking about these. We are talking about the lines that the borders that divide the zones, the regions that we are talking about, the too hot, too cold, and just right zones. They divide blue lines into segments. Oh, so this is a zone border line. Zone. It's still a region sum line, actually, but zone borders divide them instead of box borders. Okay. So zone borders divide blue lines into segments, each of which have the same total. That is the sum of its values. Remember, it's values, not digits, because there could be a too hot zone, a too cold zone, or just right zone. Oh, that's interesting. That's an interesting thing. The two ends of a blue line always lie in different zones. Ah, that is very important. Okay. So the two ends of a blue line always lie in different zones. So you cannot have, so say you had, I don't know, say if this was a cold zone, this could not be a cold zone also. It would have to be in just right or too hot zone. And that's for all region sum lines, essentially. And those are all the rules. Very cool. I've already got some intuitions from this, but I like how he's doing this. Anyways, if you like to play along, there's going to be a link in the description. And now I'm going to get started. Let's go. So the thing that I was thinking of intuition-wise, a couple of things. So for one thing, he said all 9 objects. Oh, actually, I guess that's not completely true. I'm guessing it's going to be true, but we don't know. But he says all 9 objects all contain different digits, but each object of the same type has the same value. That means there has to be a 1 through 9, obviously. So then there has to be a one of the so 3 of the digits are 1, 2, and 3, and those correspond to each other. So there's a 1 low, 1 too cold, or I guess it was 1 too hot, right? So that raises the 1 to a value of 2. There's going to be 3 that's too cold, which goes down to a value of 2. And then you have the same thing with 4, 5, 6, and you have the same thing with 7, 8, 9. My guess is that each of the bowls is going to be one of the same set, so the same entropy. So it'd be 1, 2, 3. So my guess is the bowls are 1, 2, 3, 4, 5, 6, or 7, 8, 9. The chairs are 1, 2, 3, 4, 5, 6, or 7, 8, 9. And the beds are 1, 2, 3, 4, 5, 6, 7, 8, 9. To have one bowl being too cold, too hot, and just right. One chair being too cold, too hot, and just right. And one bed being too cold, too hot, and just right. That's my assumption. But that's actually not guaranteed. Huh. I thought he was clever in doing that. Anyways. Also, we know zone borders divide blue lines into each segment, and we also know two ends of a blue line always lie in different zones. That's very important, so we know any 2-cell line has to be a border. Or has to cross a border. So we know, okay, so let's make it green because we know we're not using the color green. So this one has to be, oh, that's interesting. So we know these are different, but we just don't know what they are. So this crosses a border, this is a border, this is a border. Those are the only two. I guess this is technically a border-ish. Hmm. Interesting. I didn't explain well the region sum one. Hmm. Okay, well. Anyways, I hope that everybody understands what the region sum line is. Okay. Um. Hmm. Okay, what does these two mean? These have to be different ones. Well, we already kind of knew that. In normal yin yang, if regions are different across along a border, that means, yeah, in normal yin yang, I guess we do have to have a green because we need to mark what we see or what we know. Okay, maybe I'll make these orange. It's not that easy to see. Yellow? Yellow's definitely not easy to see. Pink? Pink isn't great either. Okay, so normally in yin-yang puzzles where there's 2 versus 1, we know that once it swaps to a different color, it cannot swap back to the same color. And I think that is still valid, but now there are 3 regions, right? Hmm. So that means interesting. Huh. The breaking in this is going to be very difficult. I think that's going to be the difficult part. No 2x2 area may be entirely within one zone. Okay. So the question is, okay, so we know this divides border. This divides this divides a border too. One of these have to be different borders. So this, okay. So this has to be this, okay, so now we're going to use pink, orange, and yellow because we don't have anything else. This has to be this way. Because I think it's similar rules, right? Once you have a region which doesn't have oh, well then that's interesting. Then the chairs actually are not too cold and too hot. That's too bad. Oh, these have to be the same region. Right, so once it breaks, so this has to be a different region than this. So we know this cannot be the same region as that. This cannot be the same region as that. This cannot be the same region as that. Once you have a break, so say like you try to have another break within. So say the pink tries to go and breaks the yellow again. The problem is that this separates the yellow. Actually, it could. Hmm. Hmm. That's a very you could do that. As long as the pink as long as the yellow's contained here, you could do that. Okay, so you're not guaranteed this. Okay, well then the chairs being too hot and too cold is still alive, guys. So you can break it if you have 3. Huh. Okay, that's problematic. That was what I was banking on to start salt to get the break in, but that's not gonna work. because you can break it, right? As long as that color stays in that region. Hmm. Hmm. Let's say this was the same. That would mean these are all... Okay, so this has to be a different color. Let's say it was like this, okay? Orange would have to have two more. So, and then pink would have to have two. Would have to have three, actually. So this would have to be pink or orange. Hmm. But we're not guaranteed that. That is problematic. This must be a different one. So this is yellow or pink. This must be, well, we don't know what these are. Hmm. This cannot be yellow, so this is orange or pink. Yeah, this break-in's gonna be difficult. These have to be different. These have to be different. This is not yellow, so this is pink or orange. The problem is that none of this information is guaranteed because we know now that you can break it along the border. Normally in yin yang you can't because if you had say a pink here and it broke here, then the yellow becomes two separate regions, right? But the problem is that this could actually be pink all the way through here, right? And then this is pink. And then you could do it something similar, right? So just the yellow has to maintain in this region. Well, obviously it'd have to have, well, it has three already, but. So this cannot be orange. This is pink or yellow. Yeah, I don't know how much this information, this is useful, because we know now you can break it. But on the edges. But you can only break once. That's the thing. You can only break once along the edge. I'm thinking it's probably here, but I don't know. Somewhere in one of these three is the break. That would be my guess. Right? Because, okay, say this was pink and you broke out on the edge and then this was pink, right? Oh, interesting. Orange has to stay in its own region then too, if that's the case. Orange would have to be in its own region. So once you break it, orange has to be okay. So you could have this, or you could have pink breaking yellow, or orange breaking yellow, or yellow breaking pink, or orange breaking pink, or yellow breaking orange, and or pink breaking orange. So those are the possibilities for the edges. Um, but once you break, they have to stay in their own region. So I don't know if that really tells us that much. Huh. And remember, region borders divide the blue line into segments of each having the same sum of its values. Hmm. Maybe this does work okay because we know once it breaks completely here, and then they have to be in their own regions, essentially locked. The yellow has to be in its own region, the orange has to be in its own region, assuming the purple's blocking is entering the other region. So this may not be bad. We just can't assume that necessarily these are the same, right? So this has to be different. So this is yellow or orange. And this has to be different. Hmm. Okay. So then the values of the chairs, the bowls, and the beds has to be 2, 5, and 8. Those are the values of it. That's not too helpful though, because we don't those aren't on any of the region sum lines. So okay, no this well, okay. This isn't the most helpful. Orange and pink, this is orange and pink. So these are different, that's fine. These are different, that's fine. Because they can always sum to it, so 3 isn't that helpful, really. Hmm. Hmm. Oh, wait. No, 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 no. It is each object of the same type has the same value. It is every. Okay. That is very important. So we know there's a break. We know there's a break. Okay. The 9 objects all contain different digits, but each object of the same type, and I missed that. It is that there is one bowl that's too hot, one bowl that's too cold, and one bowl that's just right. There's also one chair that's too hot, too cold, too high, too low, and just right. And the bed, we could say too high, too low, and just right. Anyways, so all of the objects have the same type of value. Therefore, these cannot be the same. Since they have the same value, they cannot be the same region. So now we do know. So this cannot be. So this has to there's a break. So now we have 4 breaks. So then we know this has to be pink. We know this has to be orange, and actually we now know this has to be pink because it cannot be orange because this is a separate region. Because we know this region has to be orange. It can't be yellow anymore because these two are yellow, and it can't be if this. Oh, actually, this could be orange. So either this is orange or this is pink. We actually don't know. Oh, let's try making it orange. The problem with that is how does it get through? I guess it could be something like this. And then you have orange, orange, orange. That's potentially possible. Okay. We definitely know the yellow and the pink. Those two are definitely guaranteed. So this one has to be this way. This is yellow, and this, or I think we had pink. That was pink, and this was orange. So this definitely has to be the case. And this is orange. Because we don't know anything about the chairs. And the problem is if yellow is the one who breaks, or if this basically this is broken into, we know there has to be a border either here or here. We don't know which. So these have to be different regions. So this is a separate region. So we're going to make this, I don't know, light gray and then dark gray. So the light gray matches with either orange or it's a separate thing. The dark gray matches with pink or it's its own separate thing. Okay. Interesting. This has to be, we don't know. Okay. So the orange actually still could go through, right? This still could connect. Then this would have to be dark gray. If that's the case. Okay, well, we're gonna make this yellow and gray and dark gray. Yellow and light gray. Medium gray, sorry. Just because it's easier on the eyes. This is medium gray. So this cannot be medium gray. It could be yellow. Um, Wait, can it? Yeah, it could be. So actually, that's one interesting. If this is either pink or this is either orange, right? If this is if this is pink, then it has to be, well, it's yellow or orange then, right? If this is pink, it's yellow or orange. If it goes this way, this is orange, then it has to be orange. It can never be pink though. This has to be not pink. So it could be orange. So assuming pink goes all the way across. If it's pink all the way across, it's yellow or orange also, I think. Yeah. It can never be gray because gray would be separated if this was because that was orange. So this is also yellow or orange. This can't be yellow. So if it's a cross, it can't be orange. It would have to be pink if that's the case. So if it's orange across, this would actually it could be gray. Could be gray or pink. This cannot be gray, so if this is pink, it doesn't work. It could actually be pink itself. Or it's orange or yellow. No, it has to be orange, does it? Each object type is different. Oh, that's interesting. Can this ever be yellow? Each object type. Okay, so we know this is orange. Oh. Where's the pink one? The pink bed. This can never be pink. This can never be pink. This has to be pink. That's interesting. So that eliminates orange as going through. Right? Assume orange goes through. That means dark gray is one. Oh, well, first of all, yeah, it can't be because they have the same bed. And they cannot be too high in the same one. Because all the different objects have the same value. Therefore, this is pink. Yes, we know now this is pink. So that's pink. This is pink. This is pink. Okay, this is good. And that has to be the pink. So this is to be pink chair. This is the yellow chair. This is an orange chair. Okay, good to know. This is pink, which means this is yellow or orange. Oh, it goes through. So, well, it could go this way. This is actually still possible. So this is yellow or orange. It must have one each of the bowls. So this is yellow, orange. Don't know about this. This is pink. This is yellow. So we need a bowl. This is orange. It's hard to see the borders right now. I think I deleted that one anyways. This is orange or yellow, so this has to be the same orange or yellow. Whichever it is, because it must exit out. Yeah. This is either pink or the same orange or yellow. This can't be yellow. And we know pink goes across. I mean, technically, it could go that way, and then this could be orange. So this could be pink or orange still, technically. Hmm. right? Because the pink could go that way. That's possible. And then go this way. And that could be orange. Oh, no, it cannot be. We need yellow has to connect to one of the bowls. So if that went pink, okay, so this is pink. So this is pink. It has to connect to the bowl. So if it goes here, it has to go here. If it goes from here, it has to go here, right? So this is pink. Don't know what each of these are. One of them's different though. This pink, 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 pink. This is can this ever be yellow? I don't think so, right? If this is yellow, how does it get there? It can't. It would have to block a pink. So this cannot be yellow, this has to be pink. This cannot be orange for the same reason, so this is also pink. So one of these is pink and one of these is yellow. Interesting. Hmm. Okay, so one thing that's interesting is this is only 2 digits. This is also so far only 2 digits. I think there definitely has to be some broken in between here, right? Because, um, yeah, this would be like too big. You have 1, 2, 3, 4, 5, 6, 7, 8, 9 digits, and 5 of them are already 15. And that cannot add up to, at most, so you have, say this was too hot, and there would be 8 plus 9, 17 plus 19. I guess you could have it's too low, right? 19, you have 1, 2, 3, 4, 5 all going down 1. So that's down to 10. Oh, actually, it's possible. It's possible this is all one region. Maybe. Hmm. Okay. So this is pink, this is pink. Huh. What else do we have? Hmm. This is orange. Hmm. This is pink. I think that's the only bed left. Chairs, chair. Those are all done. And then the bowls. Hmm. So actually, you could have the full blind be, if they're all lows, that could be the same region, actually. Hmm. Yellow, can yellow and orange ever interact? No. So one of these has to be pink. So we know one of those is pink. We just don't know which. Yellow and orange can never interact. Because pink also always has to be blocking them, right? Oh. Yeah, because pink goes all the way through. If yellow and orange interacted, yeah, you can't. Because orange has to be blocked on its own side, yellow has to be blocked on this side. So yellow and orange can never interact. It's always pink with orange or pink with yellow. Interesting. Okay. So assume this is yellow. That's interacting with orange. So this cannot be yellow. So this is pink or orange. This could be all three. This could be okay. This cannot be this cannot be yellow then. This is pink or orange also, right? Because the yellow cannot go through. If this was yellow, it has to connect here somehow. Orange has to connect here, and now we have two separate things. So this is orange or pink, this is orange or pink. This has to be the yellow. So since this is yellow, this cannot be orange. This is yellow. Interesting, which means this can't be yellow. So this this can't be orange. This is pink. So this can't be pink. This is orange. Interesting. So this can't interact with each other. Therefore, this has to be pink. Right? It can't be, or it could, yeah, it can't be yellow, can't be orange. It has to be pink. This is fascinating, actually. That's very fascinating. Very fascinating. Wow, that's really cool. I like that a lot. Um, yeah, let's make the coloring different then for the lines. Let's remove that. Okay, so then red? Red seems good. So red for the borders that we know are borders. So this has to be a border, this has to be a border, this has to be a border, this has to be a border. This has to be a border here. This has to be a border, this has to be a border. Right? Because yellow and orange can never be next to each other. So this is yellow. Ooh, interesting. And if all of this were yellow, oops. Say all of this were yellow. I guess the orange could go here? No. This cannot all be yellow. Because if it's all yellow, first of all, it touches orange. So that can't be. So this has to be pink or orange. Interesting. So then we can know this is pink or orange. Pink can be next to either of them. Orange can only be next to orange or pink. Yellow can only be next to orange or pink. Actually, this is not good. All of these are pink, right? If this becomes... Can it? Could this be yellow? Say this was yellow, actually. If this was yellow, does that work? Then it would connect this way. I know orthogonally they can't be next to each other, but diagonally? How does the orange connect? The orange connects that way. No, it does block it off. Yes, so it would break it apart into two. So you have the similar idea of, yeah, just anything that yellow and orange can never touch at all. So therefore, this has to be pink, this has to be pink. Because we have a yellow here and orange here, and this cannot be, yeah. So this is pink, this is pink, this is pink. Okay. Right. So then this is pink or orange. Okay. So these have to be different. So if this is pink, then these would not be different because of normal yin-yang rules, where basically if you have... The reasoning is, say this has to connect with this one if they're both the same color. The problem is that breaks the orange down into two separate regions, which is not possible. Therefore, this must be orange and this must be pink. So these have to be orange or pink. We don't know which. This can't be yellow. If this is yellow, this would have to be pink, which is possible. So these are out. Sorry, those are... Orange is there. Orange cannot go... I guess it's still... No. Yellow can no longer go this way. So this can't be yellow. This has to be orange. So this is orange, which means this is orange. So one of these is orange and one of these is pink. We don't know which. This still could actually connect that way, and that could still be yellow. But yellow has to go here, this way. So yellow's one of these two, yellow's one of those two. We don't know which. Because pink is blocking here, orange is blocking here. Orange cannot go this way because it would touch pink, so this has to be orange, which means this is pink. This has to be orange to connect this way. So this has to be orange. So now the orange is all connected here. This can't be orange. This must be pink. So this is orange. Now we have... Oh, it is a 5. Interesting. We don't know about this one. This one actually could be orange. We don't know about this. This still could be yellow here. You could have a pink, an orange, and a yellow. Let's see. There has to be a pink in between here somewhere. That's very interesting here. So these two are the same. This is pink. The pink must connect somewhere here. So it's either here. Okay, so one of these two is pink. Interesting. Okay. Yellow has to come this way. But this could be orange going that way. Oh, no. This can't be yellow. Sorry, that can't be orange. These are all purple. Right, because yellow and orange cannot talk to each other, cannot. So therefore, these are pink. Either that's orange or that's yellow. I guess it could be yellow. Yeah. There actually is an instance where neither of these are pink. So that's possible. Okay, so then that's that. So this is pink, which means this cannot be... It can't be orange. I mean, it can't be yellow, so this has to be orange. This has to be different, so this is pink. Right? This is different from these two. So now we know this. The orange must connect. It cannot be... These cannot be orange or yellow. Whoa, it's a yellow. One yellow. Huh. So this is pink. These must connect, so this has to be orange. Fascinating. So the yellow is here. We now know what this is. Yellow is cold. Or sorry, yellow's hot. Because it's 1 digit. That must equal 5 digits in a column. Actually, 6 digits in a column. And the only way that works is if this value is 10 and this is a cold. So the yellow has to be hot. And the orange has to be cold. And the purple is just right. Okay, now we can remove the red. I don't know if... Okay, we don't really need the borders anymore because we know certain things now. We're just going to remove the... Okay. So these are all cold. We also know this is a 9. So this is a 9 in value. This has to be 1, 2, 3, 4, 5, and this is a 1 because this goes down to 0 plus 10. So this is 1, 2, 3, 4, 5. Obviously, there's no 1 there. This is 6, 7, 8, 9. This is 6, 7, 8, 9. This can't be a 9. So this is 6, 7, 8 because that's the same one as this one. And it's just right. And this is cold. So this has to be 7, 8, and 9 because this goes down 1. So this is 10. This is 10. This has to add up to 10. So it's 1, 9. It can't be 1. It could be 2, 8, 3, 7, or 4, 6. This must add up to 10. So this can't be, this could be 1 and 9, 2, 8, 3, 7, 4, 6. So this adds up to 10. Okay. This blocks off it from being blue, so this cannot be blue, right? The blue can no longer, well, I guess, no, it can't be there, right? If that goes there, then, okay, so this is red. This is green. That's fine. We don't know about this. This is just right, so this is 2, 5, or 8. This is 2, 5, or 8. And where is it just right? This is a 2, 5, or 8. Okay, it cannot be 8 because this can't be 9. So this has to be... This is going up 1. Oh, wait, it could go up 1. So this is 1, 4, 7. It can't be 1, though, because of that. So this is 4, 7. So this has to be 5 or 8. So this has to be 6 or 9. It can't be 9, so this is 6, which means this is 4 and this is 5. So there's no 4, 6 available here, no 4, 6, therefore, in this set. This can't be the 4. Interesting. I like it. Like it. So this 4, 5, 6. This cannot be 5 anymore. This can't be 5. It's 2 or 8. So it's... This is 3 or 9. This is 3 or 9. This is 1 or 7. And this is 1 or 7. So we have a 1, 7, 1, 7 pair, which means there cannot be a 7 in the rest of the column or row. This can't be 3 then, because this has to add up to 10. What is this? Okay, so this is green. It has to connect somewhere through here or here. So this, one of these is green, one of these is green at least. One of these is green. One of these is red. One of these is red. Okay. You cannot have 4 reds here, because that adds up to 1 green. So I think the green has to be the next one, right? I mean, it could be this is red and then this is 2 greens, possibly. Yeah, I mean, that's possible. Oh, no, okay. If this is red, this has to be green, so then this would have to be red. And then, I guess it could be like that? But then you would have green and green, which is, and they would have to be the same number. So that does not work. So if this is red, this has to be red also, because this has to be green. So if this is red, this has to be green, which forces this to be red, which means either one of these two are red. But the problem is that if this is red, you have 4 digits which add up, which go up by 1 each. So that's a minimum like 14. And then that equals 1 digit. So that doesn't work. If this is now green, though, you have green and green, which equal the same number, because the zone borders, remember, are the ones that divide the region sum line. So then that would be green and that would be green, and they would both be the same number, and that's not possible. So this cannot be red. This has to be green, which means this is the red. So the red has to go here. We don't know which way now. This is red. So this cannot be red. This has to be green. Because the ends always have are in different regions. Therefore, we know this is red. Therefore, that's red. So this is connected that way. So this is all red. This is green. The green is connected here. So it's one of these two. We don't know. Actually, it could be neither. But it has to be one of them. So it connects this way. Green is one of these two. We don't know which. So red's connected. This can't be red. This has to be green. This could be red. Actually, no, we know this is green. So this is green, which means this has to be red. Okay. So this has to be green to connect. Again, one of these two is green. This can't be green, so this has to be blue because it can't be red anymore. So again, one of these is green. One of them is not green. We don't know which. This is either green or red. We don't know which, though. This could be green or red. This could be green or blue. Again, these could be green or blue. And this is green or red. This is green or blue. This is green or red. So it's either that or it's this way. And you could have 4 digits that way adding up. Oh, I guess this was minimum 7 plus 4, which would be 11. But yeah, same logic still. So this is green and red. These two are the same. These two are the same. And they're 1 apart from each other. This is 1717. 39. This is 39. These two add up to that. These are the same. Oh, this can't be blue. So this is red. It can't be green. So this is red, which means none of these can be blue. So these can't be blue. These have to be green. This has to be red now to connect. This can't be blue anymore because that's green. So this is the way it connects. One of these is red. One of these is green. We don't know which. Huh. So this is, yeah, like I said, I was thinking it could be 1, 1, and 1. They're all the same. Interesting. So this is the same as that, which means this is staying the same, and this is going down. So this could be 7, 8, and 9. Could it be 5? 5, 4, 3, 2. So then this would be 1, which it can't be. So this is 2, 3, 4. So this can't be 2. 2, 3, 4 to correspond, and then 7, 8, 9. That's 7, 8, 9. This would be 6, 7, 8. So 6 is one of these two. So therefore, 6 is one of those 3. This can't be 1. It can't be 9. So this is 2, 3, 4, 5, 6, 7, 8, which means this is 1 less than this. So this is 1, 2, 3. 4, 5. 4, 5, 6, 7. Can't be 5. So since this can't be 5, this can't be 6. One of these is green. Since if that's green, this has to be red, red. If this is green, you could technically have all 4 of these add up to that. One of these is green, one of these is red. We don't know which is which. One of these is green, one of these is red. We don't know which. If this is red, this is green. I don't know if that's anything. One of these is red, one of these is green. We don't know which again. 1, 7, so this cannot be 1, 7. It cannot be 6, 4, 5, or 9. So this has to be 2, 3, or 8 here specifically. So this goes down 1. So this would be 2, 3, 4, 6, 7, 8. And then this would go up, down 1 again. So this is 1, 2, 3, 5, 6, 7. All right, because all 3 of these are equal. This adds up to 10. We already have that. This adds up to 10. This is 10 in value. This cannot be 1, 4, or 6. So this has to be... Can it be 2? Yeah, maybe. 1, 2 seems fine. Could be 2, 1. So it could be 2, could be 3, can't be 4, could be 5, 7, 8, or 9. So it's a value of 3, 4, 6, 8, 9, 10. Okay, so this could be 2, 3, 5, 6, 7, 8, 9, which means it goes down 1 in the red. The red goes up. So this is 1, 2, no 3, 4, 5, 6, 7, 8. It can't be 6 here, so this can't be 7. Because the 6 is one of these three. Okay. These are the same. So this can be 1, 2, 3, 4, 5, 7, 8. Cannot be 9 because the 9 would become 10 in value. So this is 1, 2, 3, 4, 5, 7, 8. This is 2, 3, 4, 5. It can't be 6, 7, 8, 9. So that corresponds to this not being 5. So this can't be 5. So then 2, 3, 4, 5, 7, 8, 9. These are the same. These are the same. We just don't know which one it is. 1 and 7 go up. 3 and 9 go down. So this cannot be 3, 9 because it sees both. So it would have to be... This can't be 3 or 9 because it sees both. So this is 1, 2, no 3, 4, 5, no 6, 7, 8. So this can't be 1 because of that. 2, 4, 5, 7, 8. This is also, instead, this is 1, 2, 3. Can't be 3. 1, 2, 4, no 5, 6, 7, 8. Cannot be 9. Okay. This is 1, 2, 3, 7, 8. All of this is 1, 2, 3, 7, 8. 1, 2, 3, 7, 8. 1, 2, 3, 7, 8. If this is 1, this is 2, this is 3. If this is 7, this is 8, this is 9. Okay, this sees both 2 and... Oh, all of these see the 2 and the 8. Because either of these are 2 or 8. So this cannot be 2. This can't be 2 or 8. This can't be 2 or 8. So it's 1, 3, 4, 5, 6, 7, 9. This can't be 2 or 8 because it sees both 2 8s. So this has to be... It can't be 1 or 7. So this is 3, 4, 5, 6, 9. These both see 2 and 8, so this cannot be 2 and 8, right? These two cells both see these, so this can't be 8. So this is 6 and 9. This is 6, 7, 8, 9. So 8 is over here. This has to be 8, which means this can't be 8, so that can't be 7. This is 3 and 7 or 4 and 6. We don't know which. So this cannot... Okay, so this is 6 or 7, which means neither... This can't be 6 and 7 then. So this cannot be the 6. That can't be 7. It cannot be 7. So therefore, this is the 6, which means we know what this is. This is 6 in value, so this is 7 going down. So this is 7. This is 8. This is 9. No 7 or 8. The 3 has to be here, so this can't be 3. This is 6, 7. So this is 6, which makes that 5. So this cannot be 5. This can't be 6. This can't be 8 because of that 8. This can't be 6. That can't be 7. So this cannot be 5 or 6. This can't be 9 anymore. This can't be 8. This can't be 9. So this is 8 and 9, which add, so this is 8 because it must add up to the same box borders. So no 8s here, no 8s here. This now has to be a 3. So the bed is a 3, which means this bed is a 1. That's 3 in the corner. Let's celebrate. This is a 1. This is a 7. The beds are 1, 2, and 3. So this is 2. This is 8. So this cannot be 7 anymore. This can't be 7. This can't be 8. This can't be 3, 7. So this is 4, 6. So the 4 cannot be here. This can't be 4. This can't be 2. So this is 1 and 5. Therefore, this is 2, 3, 4. And this is 5. So this can't be 5 here. This can't be 5, 4, or 6. So this is 9, which makes that 3, which makes that 2, which makes that 3. No 1 or 3. This has to be a 1 because 2, 3, 7, 8 are eliminated. So this is 7 because all the rest are eliminated. This is regular Sudoku here. This can't be 1 or 7. No 1 or 7. This can't be 7. This can't be 1. This can't be 5. This can't be 5. So this is a 4, 9 pair. If this has to... Okay, so this has to be 9 then. Say this was a 4. No matter which way this goes, if this is green or red, it would have to be 3 plus 9 or 4 plus 9, and neither of those are equal to 3 or 9, or even close to it. So this can't be 8, no 7, 8, or 9, no 8, no 9s here, no 2 or 3. This is 4 and 6, so therefore this is 8. Now we're just doing Sudoku. This can't be 8. This can't be 7, so that can't be 7. So now it's 2, 3, 4. Wait. Oh. So this can't be 2 then. This is 3 or 4. This has to be 2 or 3. And this is 3 or 4. So 3 is always here. So this can't be 3. So therefore this is... Well, we already knew that was 9. So this is 9 because of the chair. Because all objects are the same. This can't be 7. So this can't be 9. Again, this is 9. And then this has to be 4, which means these two are red. So they are red because 1 plus 1. So this would be value of 4, value of 5 equals value of 9. So this cannot be red. This is green. This now just become a 6 because of Sudoku. 4. That's a 7. This is a 2 or 4. We don't know which. This we have a 2, 3, 4 set in row 6, so this is 1 and 8. This is 1 and 8. 1, 2, 3, 4, 7. Okay, so this is 7 in value. Could be 7 in value here. That's fine. Now we just have to do Sudoku. Okay, so this is 6 and 7, which means 5 and 6 in value. We have a 9, but that can't be here, so this has to be 9. So this is 9 with 5 or 6 in value, which means we need a 4 or 5 in value. The 5 doesn't work because this is 6, so this has to be a 4 in value. Right? Wait, this is 5 or 6. No, sorry, 3 or 4 in value. So then this is 4 or 5. We have 4, 5, 4, 5. Okay. This going down, so this can be 3 or 4. Right? Going down in value, it's 3 or 4. This has to be 7 then. So this is 7 and 3. So this is 4, 5, because it has to add up to 10. And so there was nothing else that adds up to 10 except for 7, 3. So this is 1 or 2. This is 1 or 2. This has to be 4 then. This is 2. This is 2. This is 4. So this is a 3 in value, which means this has to be a 6 in value, so that's 7. This is 6. No 2 here. No 2 or 3. No 2. So this can't be 2 either. Okay, so this is 5 goes down to 4, or 6 goes down to 5. So this can't be 2. This can't be 8. This is 5 or 6. This is 5 or 8. We have 5, 6, 7, or 8. This is a value of 6 or 9. So 6 would have to be 1, 5, or 2, 4. So this can't be 4 here right now. Or it's 9, which means 1, 8, 2, 7, 3, 6, or 4, 5. It cannot be 4, 5 because we have a 4 and a 5 here. Therefore, this has to be add up to a value of 6. So this is a 5, which makes that a 6, which makes that a 5, which means this is 2, 4. It means this is 1, this is 3, this is 4, this is 8, this is 1, this is all because of Sudoku. Now this becomes 3 and 3. This is 2 and 2 to satisfy the 2 hot and the region sum line. This is 4. This has to be 9. This has to be a 7, 8 pair. So 5 and 6, 5. This is 6 in value, which equals 6. Okay, so then this becomes a 2. Now we have, this is 1 and 2. What do we have left here? This is 1, 6, 1, 3, or 6. So this is 1 or 6. This is 1, 3, or 6 here. So this has to have a 3, which is normal value. Okay. Okay, so now we have, this is 5 or 6. This is, what, 7, 8, 9? Yeah. So 7, 8, and this is 9. Or this cannot be 9. So these can be 9. This could be 3. So 3 is one of these two. And we have 7. This can't be 7, 8, or 9. So this can't be 7, 8. This has to be 3 because of Sudoku. So this is 3 now. This can't be 3. This can't be 3. This can't be 7 or 8. So this is the 9, which means this is 7 or 8. This can't be 9. This has to be 9 in value. We have 1, 2, and 7 or 8 here. So this could be 1, this could be 2, and either of them could be 7 or 8. We have 1, 6, and 5. So this is 5 and 6, and this is 1, 5, or 6. We have a 4, so that can't be 4. Therefore, this is 4. And this is 1 of 1 or 2? No, 1, 2, or 6. Can't be 1, so this is 2 or 6. Okay, so if this is... No, this is interesting. So now we're just figuring this out. If this is red, these cannot be the same, so this would have to be red. So if this is red, this is red. If this is green, we know there's a 6 in there. And so this is 6 and 1 and 3. So if this was green, well, this could be red. If this is red, this has to be red because of it cannot be the same one. If this was green, that would make this okay, 8. This is 7 in value, which cannot be. If this was just the only green, this would have to be blue. But then this is 6 in value, and this would have to be 8. So this cannot be 6 in value. Also, this has to be 7 or 8. Because there's no other place for 7 or 8. This can't be 7 or 8. This can't be 7 or 8. And this can't be 7 or 8. So this has to be 7 or 8, which means this is 1. So this is 5, 6, 5, 6, which means this is 1, this is 6. So this is 2, 2, 1. And now we're just, that was all Sudoku. So again, this is being 1. This, even if this is blue, if they're both blue, this does never get to 7 in value. So this has to be green. And because this is green, this cannot be green, so this is red. We kind of already knew that, though. So this is 6, this is 5. This is then 6 and 5, because Sudoku. This adds up to 10 already. Or sorry, 9. This is 9. If this was all red, this is at minimum 13. So this cannot be red. This has to be green. So this is green, which means this is red. And these add up to 11. Is that right? 2 plus 3 is 5 plus 6 is 11. Right. So then this is a value of 2, and this has to have a value of 9. So this is 8, this is 7, this is 8, this is 7, this is 8, and this is 7. And that's the solution. Very clever. I love it. Love the rule set. Love the Goldilocks theme. Congratulations, the solution is just right. It is at that. And so was this puzzle. And I hope you had a just right situation too in watching this solve. And I'll see you next time on Frank Puzzles. Take care.